Good day everyone, I am Jane Catherine Filselda and today we're going to dive into the concept of hypothesis testing, a critical tool used in decision making, especially in situations involving uncertainty, whether you're a business professional, researcher, or simply someone interested in data analysis. So hypothesis testing is invaluable in making informed decisions based on statistical evidence. Now let's break this concept down and see how it applies to a real-life scenario. So, unsa man gid ang purpose and importance in decision making? So, hypothesis testing helps us to make decisions or inferences about population based on sample data. It also allows us to assess the validity of a claim or assumption, often under a conditions where there is uncertainty. In essence, hypothesis testing provides a structured framework for evaluating whether the data supports a particular belief or hypothesis. Why is this important? It helps businesses and researchers avoid costly mistakes by using statistical evidence rather than intuition alone. So, whether you're deciding on a new strategies, improving a product, or determining the effectiveness of a policy, hypothesis testing gives you the clarity and confidence needed to make the sound decisions. So in hypothesis testing, we work with two competing hypotheses, the null hypothesis and the alternative hypothesis. So what is null hypothesis? So it is the assumption that there is no effect or difference. It's the hypothesis we seek to test and potentially reject. It represents the status quo or the existing condition. And the other one is the alternative hypothesis. It is the hypothesis that there is an effect or difference. It's the outcome we're trying to provide evidence for. Now, come to think if like a courtroom, the null hypothesis is the defendant presumed innocent and the alternative hypothesis is the accusation. We test the evidence to decide whether we have enough proof to reject the innocence of the null hypothesis. So, example is Oxford serial scenario. Let's consider a practical example. Imagine, Oxford Cereals is wondering whether it should adjust its cereal filling process to increase the amount of cereal in each box. Currently, they are filling each box to a target weight, but they suspect that on average, the actual weight might be slightly under the target. To make a data-driven decision, they would conduct a hypothesis testing. So, the null hypothesis is the average weight of the cereal in each box is equal to the target weight, while the alternative hypothesis is the average of weight of cereal in each box is less than the target weight. So, in this case, the Oxford cereals would collect a sample of boxes, weight them, and test whether the average weight is significantly different from the target. If the sample data provides strong evidence that the average weight is indeed less than the target, they may decide to adjust their filling process. In summary, hypothesis testing is an essential part of decision making. By formulating a null and an alternative hypothesis and collecting sample data, we can make informed decisions backed by statistical evidence. In our Oxford cereals scenario, it would help determine whether adjustments to the filling process are necessary or if the current process is adequate. So, thank you for your attention, and I hope the next reporter will discuss it more efficiently para mas masabot.
Hello everyone, good morning. Let us discuss the critical value of the test statistic, a key concept in hypothesis testing. The critical value of the test statistic. This concept helps us determine whether our results are statistically significant or merely due to chances. In hypothesis testing, the critical value acts as a threshold. It separates the rejection and non-rejection regions for the null hypothesis. If our test statistic exceeds the critical value, we reject the null hypothesis. But first, let us know what is the importance of the topic. A business can make data-driven decisions, helps researchers and businesses make informed choices rather than relying on guesswork. Second, reduce error analysis, ensures we avoid incorrect conclusions based on random fluctuations in data. Lastly, increase confidence in results, helps determine whether our findings are statistically valid and not just due to chance. So let us continue with the hypothesis testing. It involves determining how likely the null hypothesis is to be true, considering the data collected in a sample. So to further explain this, Let us say there is a factory of Taro Green Crunch and the weight of each pack is 50 grams, and you need to calculate whether all the packs are even. So now, you select a sample of each box to determine its sample mean. So after you weigh each pack, we will have our sample mean. Now, we can determine if the null hypothesis, whether it is true or false. So the question is, how we will know, how do we know if it's true or false? Simply, if the pack is 50 grams or the critical value is 50 grams, the sample mean must not be far from 50. For example, 49.9 to 49.5, because the significance level common values are 0.05 or 0.01, and the numbers 49.9 to 49.5 are around that number, 0.05 or 0.01. So representing the probability of making a type error. But when the sample mean goes way below the sample mean, like 30 grams, now you can consider that the null hypothesis is false. In short, if the critical level is 50 and the number of the sample mean that you calculate is 49.9 to 49.5, the answer of the null hypothesis is true. And if the number that you calculate from testing the pack of every green crunch is 30, and now the answer is false. That is how you define the hypothesis testing. So to make it more relevant to you guys, I have an example. This Let's say a teacher claims that students in their school score an average of 80 on an exam. To verify this claim, a researcher takes a sample of 50 students and computes their average score using hypothesis testing. We calculate the test statistic, compare it to the critical value to decide whether to reject the teacher's claim. Now that we already know the critical value of the test statistic, let us proceed to regions of rejection and non-rejection. So this is just a part of the topic critical value. I'm just um, having an example here. So here, this is a graph of the region of non-rejection. So here we can see that this part is the region of rejection, and here also. And at the middle is region of non-rejection. Critical value and critical value. Now, the region of non-rejection, let's say the numbers of critical value is 50, like the example earlier, 50. Now, what's inside of the region of non-rejection here is the number 49.9 to 49.5, and the number of region of rejection either is 30 or above 50, like 60 or 70. Okay, that's all. Um, thank you.
Hi everyone. Today, I'll briefly explain type 1 and type 2 errors. The type 1 error or alpha happens when we reject a true null hypothesis. This is a false positive which can lead to wrong action or conclusion. The type 2 error or beta occurs when we fail to reject a false null hypothesis. That's a false negative which may cause us to miss a real effect or risk. Alpha is the significance level on which lower alpha means fewer false positives, while the beta is the risk of misdetection, on which lower beta means we're better at catching the real effects. The confidence level is 1 minus alpha on how sure we are in our decision. The power of tests is 1 minus beta on how likely we are to detect a true effect. Let's look at an example of type 1 and type 2 errors using a real scenario. Suppose we want to test the claim that the average height of adult woman is 165. That's our null hypothesis, or HO 165. We collect our data from a sample of 40 women and we find that their average height is 163 centimeters. Using statistic, we calculate the z-score of negative 2.5 at a significant level of alpha equals 0.05. The critical z-values are positive to negative 1.96. Since negative 2.5 is outside the range, negative 1.96 to 1.96, we reject the null hypothesis. This means we conclude that the average height is not 165 centimeters.
Z-test for the mean when the population standard deviation is known. The z-test is a statistical method used to determine whether a sample mean significantly differs from a known or hypothesized population mean when the population standard deviation is known. Z-test is used when the population standard deviation is known. Z-test is also used when data is normally distributed or the sample size is 30 or more. You can also use z-test calculation when you're testing whether the sample mean differs from a population mean. This is commonly used in manufacturing, quality control, and research setting where population parameters are established. Here is a step-by-step calculation of z-test. Step 1. State the hypothesis. There is two, the null hypothesis and the alternative hypothesis. Null hypothesis is when the population mean is equal to a specific value. Alternative hypothesis is when the population mean is not equal to a specified value, the population mean is less than the specified value, or the population mean is greater than the specified value. It depends on the question. Step 2. Identify the known values. The known values are the population mean, population standard deviation, sample mean, and sample size and the significance level. It is usually on the 0.05. Step 3. Calculate using the z-test calculation or formula. Z is equals to the sample mean minus the population mean divided by the population standard deviation over the square root of sample size. Step 4. Determine the critical value or p-value. Use the z-table to find the critical value for the chosen significance level. Step 5. Make the decision. It is you can either reject or accept your hypothesis. So for example, a cereal company claims its boxes contains 500 grams of cereal. A quality inspector wants to test this claim. So given that the population mean is 500 grams, the population standard deviation is 5 grams, the sample size is 36, the sample mean is 498.5 grams, and the significance level is 0.05, using the left-tailed test. So step 1, you should create your hypothesis. So the null hypothesis is population mean is equal to 500, and the alternative hypothesis is the population mean is equals less than 500. Step 2, you should calculate this for a given using the z-test formula. 498.5 minus 500 divided by 5 over the square root of 36. So if you calculate that and everything, may equal siya og negative 1.80. Step 3, finding the critical value for the significance level, which is like 0.05. So when you look at the z-table, you're looking for the z-score where the left tail or area under the curve to the left is 5% or 0.05. So basically pangitaon sa Z table, pangitaon nimo ang value nga um duol or like duol or exact gauge sa imo ang significance level. For this one, the z-score that corresponds to a cumulative probability of 0.05 is the negative 1.645 or the 1.665. Step 4, since the negative 1.80 is less than negative 1.645, we reject the null hypothesis. So in conclusion, there's statistical evidence that the cereal boxes contains less than 500 grams on average.
Good afternoon, sir. So what is the definition of p-value? The p-value is the probability of obtaining a test statistic as extreme as or more extreme than the value observed in your sample data, assuming the null hypothesis is true. In simpler terms, it tells you how likely your sample results would be if the null hypothesis were correct. As you can see on the screen, there are the sample problem, the solution, and the steps. As you can see, our p-value is greater than the alpha, which is the 0.1336 greater than to 0.05. Since the p-value is greater than the alpha, you fail to reject the null hypothesis. It because there is not enough evidence to say that the mean weight is different from 368 grams. Now, when to reject and retain the null hypothesis? The decision rules for rejecting in the p-value approach are: if the p-value is greater than or equal to, do not reject the null hypothesis. But if the p-value is less than, then reject the null hypothesis. What are the advantages over critical value method? The p-value is more informative because it gives the exact level of significance of your result, and it tells you how likely your sample results is under the null hypothesis, while the critical value only tells you whether to reject or not, not how strong the evidence is. Also, the p-value is easier to interpret and compare. You can compare the p-value to any significance label. Example is 0.01, 0.05, and 0.010, while the critical value method is locked to the pre-chosen pre-chosen. Now, how about testing and rejecting a null hypothesis using the p-value? As you can see on the screen, on this example, we can apply the 5-step p-value approach. Since we are testing whether the population mean has changed, so it's a total test. For step 1, state the null and alternative hypothesis. Step 2, choose the significance level of the alpha or the alpha. Step 3, compute the test statistic. And step 4, find the p-value. And last, make a decision. As you can see, on the example, our p-value is less than to alpha. Since our p-value is less than to alpha, we reject the null hypothesis.
So let's proceed in confidence interval and hypothesis testing. So the confidence interval is a range of plausible value for the population parameter. So ang confidence interval is a range diya nga dito na nato masukod or makita ang true value. Then ang hypothesis testing is a way or a method to check if the guess value is falls within a range, and ma-check po nato of reasonable ba siya or not. So for example of cereal box weight with 95% confidence level for the mean cereal box weight between 495 to 505 grams. So let's say for example, ang guess value ni Mitsuki is 500 grams. So, we can say nga, iyang guess value is nasya sa sulod sa range or within the range. Kaya ang atong limit man is 495 to 505 grams. So, kaya ang Kamitsuki kay 500 man, nasulod siya sa confidence interval. Then, we can say nga, ang iyang guess value is acceptable or reasonable. Then, another example, if ang guess value ni Ziniel is 490 grams, so, we can say nga, dili siya acceptable kay nasya sa gawa sa range or sa confidence interval which is 490 grams. Then, ang atong confidence interval is 495 to 505. So, that's all.
So now let's talk about the t-test of hypothesis. So for the mean when the population standard deviation is unknown. So the t-test of hypothesis for the mean when the population standard deviation is unknown is used when you want to make inferences about the population mean based on a sample, but you don't know the standard deviation of the entire population. So in a simple term, the test or the t-test allows you to proceed with your hypothesis test using the sample standard deviation as an estimate. So now let's proceed with the problem solving, which is the Saxon home improvement scenario. So first, we need to understand the problem. So the goal is to determine if the current mean amount per sales invoice is different from the past 5-year average of mean equals to $120. So we need to perform a hypothesis test. And second is to set up a hypothesis. So we want to know if the mean is different from 120, it's either increasing or decreasing. So this indicates a two-tailed test. First, we have here the null hypothesis, or the mean amount per sales invoice is unchanged from the past 5 years, or M is equals to 120. And the alternative hypothesis is the mean amount per sales invoice has changed from the past 5 years, or M is not equal to 120. So the third one is to we need to determine the sample data. So we have here the sample size, or n is equals to 12, and sample mean equals to 12.85, and sample standard deviation equals to $20.80. So, and the fourth one is to choose a significance level, or the A. So let's assume a common significance level of A is equals to 0.05. So this means that we are willing to accept a 5% chance of rejecting the null hypothesis when it is actually true. So number 6 is to determine the degrees of freedom. So the degrees of freedom, or the DF, for a kanang one sample t-test are n minus 1. So our sample size is 12. So we're going to subtract it to 1. So n minus 1 is equals to 12 minus 1 is equals to 11. So next is to determine the critical value from the t-table for an area of 0.025 in each tail. So now we have 11 degrees of freedom. So from that t-table, as you can see in the screen, that the critical values are the decision rule. So we have here that t-stats is less than negative 2.2010, or if the t-statistics is greater than positive 2.2010. Otherwise, we will not reject the hypothesis. So now let's calculate the t-statistics. So the formula is t is equals to sample mean minus population mean over sample standard deviation and over square root of sample size. So here we have 112.81 of sample mean minus 120 of population mean over 20.80 of sample population mean over square root of 12 na sample size. So with that, we have here negative 7.15 over 5.999, and it is equals to negative 1.192. So we do not reject the hypothesis. Because we did not reject, we have insufficient evidence to conclude that the mean amount per sales invoice differs from $120. So the audit suggests that the mean amount per invoice has not changed.
Now, comparing critical value and p-value approaches in t-test. Critical value approach, it could be determines whether the calculated t-statistics falls into rejection region defined by a critical value. And the steps of this approach is the set of hypotheses and choose a significance level of alpha. and then calculate the t-statistics from sample data to determine the critical value from t-distribution tables based on an alpha and degrees of freedom. And then p-value approach, it calculates the probability of p-value to obtain a test statistics as extreme as the observed one, assuming null hypothesis is a true. Then a step of this is set of hypotheses and choose a significant level of alpha, and then it calculate the t-statistics from sample data. Also, it determine the p-value corresponding to the t-statistics. And the key differences of this uh, critical value and p-value based on decision basis, and then in flexibility and interpretation. First, in decision basis, critical value, it compares t-statistics to a threshold value, and then p-value compares probability to significance level. In flexibility, critical value are less flexible than p-value because p-value is more flexible, allows for more interpretation or more masabtan ang interpretation. And then sa interpretation, critical value is a binary decision. It could be reject or not reject the null hypothesis. And then in the p-value, it indicates strength of evidence against null hypothesis. Lastly, both approaches ultimately serve the same purpose, to assess the evidence against the null hypothesis. The choice between them often depends on context, available tools, and preference for better interpretation for the problem.
So today we're going to talk about hypothesis testing, a key concept in statistics that helps us make decisions based on the data. Let's start with the basics. What is hypothesis testing? Hypothesis testing is a method used to determine whether a claim about a population is true based on sample data. It helps researchers and businesses make informed decisions. Now, before we conduct a hypothesis test, we need to consider some assumptions. One of the most important assumptions is normality. So, the importance of normality for hypothesis test: to be accurate, the data should be approximately normally distributed. This means the data should follow a bell-shaped curve. We can check this using histograms, box plots, or normal probability plots. But what if the data isn't perfectly normal? That's where t-tests come in. Robustness of t-test. The t-test is a common statistical test used to compare means. The good news is that t-tests are robust, meaning they still work well even if the data isn't perfectly normal, especially when the sample size is large. However, if the sample size is small or the data is not normally distributed, we need to use non-parametric alternatives. So when to use non-parametric test? Non-parametric tests don't rely on normality. One example is the Wilcoxon rank sum test, which is used when comparing two groups without assuming a normal distribution. So, understanding hypothesis test helps businesses, researchers, and analysts make. Understanding hypothesis testing helps businesses, researchers, and analysts make data-driven decisions. Whether we're testing a new product, analyzing customer behavior, or conducting scientific research, hypothesis testing ensures that our conclusions are reliable and accurate. So, to summarize, normality is important for hypothesis test. T-tests are strong even if normality is violated, but they work best with large samples. Non-parametric tests like the Wilcoxon rank sum test are useful when data isn't normal or the sample size is small. By applying these concepts, we can make better decisions based on data. Thank you for listening.